Hello everyone, welcome back to our channel. The topic for the today's discussion is amexines. We all know that the treatment of wastewater plays a very important role in our daily lives. The 21st century is the era of nanotechnology. Different nanomaterials are successfully utilized for treating the different kinds of the wastewater having the different sources. In this connection, nowadays, the scientific community completely focused on the type of materials called amexines. These amexine materials are the transition metal carbides or the transition metal nitrides or the transition metal carbonitrides. The first amexine Ti3C2TX was discovered at Drexel University in 2011. Before 2011, people were used the chemistry of graphene. Graphene chemistry is very successful chemistry. Nowadays, different kinds of graphene materials are also used for the same purpose. But this is the era of amexines. Amexines plays a vital role nowadays in different kinds of the applications along with the environmental remediations. So exactly what are the amexines? If you see the formula Mn plus 1 xn tx, here n is a number 1 2 3 4. The first element is M stands for early transition metal. These are the metals which can placed in the molecule. X, it may be a carbon or it may be a nitrogen. That's why the people are saying transition metal carbides or transition metal nitrides. Sometimes the molecule may have both carbon and nitrogen, so we can say carbon nitrides. The Tx refers to the surface terminations. It may be O minus, OH minus, F minus, Cl minus. These kind of atoms or groups may be associated as the surface termination. So generally, if you see, how can we prepare the amexines? So amexines are generally prepared from max phases. So what is the general formula of max phase? Mn plus 1 AXN. Here M stands for early transition metal. A represents elements from groups 3rd A and 4th A in the periodic table. X is either carbon or nitrogen. So if you see the difference between the max phase and the amexine, the A is replaced with TX, right? So if you see the picture, here we are having different colors of the balls. If you see this area, the red color indicates A. A represents elements from group 3rd A and 4th A. These aluminum, gallium, indium, thallium, silicon, germanium, tin, lead, right? 3rd A and 4th A. These are the elements. Sometimes the phosphorus, sulfur, and cadmium can also be present in the mx phase. Thereby we can get corresponding amexines also, but in most of the cases we are going to have 3rd A and 4th A group metals in the max phase. So what we are doing from the max phase to amexine, the thing is that the termination of the A indicates 3rd A or 4th A group elements are going to be removed from the max phase. So if you see the methodology, how can we prepare amexines? So generally we are going to take max phase. Here see this one, Ti2AlC. So this is the 3rd A group element or not? So these are the max phases. Max phases are subjected to the etching phenomena. Okay, followed by the sonication with stirring. Under these conditions we are going to get the eliminated 3rd A or fourth A group element. So after the elimination, we are going to have general characterization, XRD, SEM, TEM, XPX, BET, surface analysis, everything as like different kinds of the nanomaterials. We can also have these kind of material characterizations. The main reason for this particular topic is that our research group is nowadays focused on these kind of materials. As we know, MXenes have different kinds of the applications. We have concentrated on environmental remediation, especially for the treatment of wastewater. Recently, our group has published one of the good article in the journal Chemical Engineering Journal. Now, with the impact factor of 13.3, it is one of the good journal with Q1 quartile. If you see the title, Revolutionizing Industrial Wastewater Treatment, MXenes were organic pollutants in a paradigm shifting breakthrough towards the sustainability. Nowadays, we are having the sustainable developmental goals, 17 goals we have. So in order to achieve these goals, the scientific community at the global level is continuously working, right? So our group is also participating in the same. So in this particular article, my authorship position is the first one, right? So currently I am working in Presidency University, Bangalore, right? So if you observe the MXene materials, MXene materials nowadays used for the treatment of wastewater, right? The wastewater contains different kinds of the pollutants, either organic pollutants or the inorganic pollutants. This particular article concentrated on the organic pollutants, majorly dye degradation. So if you take different kinds of the industries, industries are going to provide the wastewater containing different kinds of the dyes, especially textile industry. So in order to degrade the different kinds of the dyes present in the wastewater, how the MXene materials are useful. So this review article completely concentrated on 84 MXene based photocatalyst. Generally, we know that for the dye degradation, we are using the phenomena called as photocatalysis. So, photocatalysts, right? So in this particular article, we have compiled the data of 84 different kinds of the MXene based materials for the degradation of 31 organic pollutants. So it is very important article, highlighted the chemistry of 84 MXene derivatives for degrading 31 organic pollutants, right? So if you see this particular article, generally wastewater contains these kind of dyes, methyl orange. If you see the particular mechanism, after the degradation, what is happening? Whatever the dye we are having, that is converted into CO2 and H2O. So here we have highlighted the mechanism of all 31 different kinds of the dyes. See, rhodamine B. See the pathway. According to the pathway, we are coming up with this kind of moiety. This can further converted into CO2 and H2O. Congo red. See the mechanism. It is converted into phthalic acid. Again, malonic acid, succinic acid, and other simple acids finally converted into CO2 and H2O. So how the MXene materials degraded these kind of moieties? That is very important one. So as a chemist, we need to understand the chemistry behind the degradation. So this particular article really explored the mechanism of degradation of different kinds of the dyes by using the amexine kind of materials. See the malachite green. So almost all in all the cases, we are coming up with what? CO2 and H2O. So different kinds of the dyes. We are having 31 dyes data has been placed in this particular article. And if you see the summary portion, see here we have provided the data in the form of table. So all the materials which were utilized by the scientific community have been compiled in this particular article. So this particular article is very much helpful to the scientific community. If you see this particular table, we have given all kinds of the nanoparticles and the nanocomposites, and also the type of the polluter, what kind of the dye is degraded, what is the time required, and how much absorption capacity, elimination or efficiency capacity of the material. Everything has been given in this particular table. So based on the particular table, the new researchers can design some of the novel amexine materials for the further studies. So whenever we conduct a research on these kind of things, we should have the literature. That literature is readily available with this article. That's why this article is very, very important. If you see the first one, the first material here, it was used for the degradation of the methylene blue, right? 97 percentage efficiency it has been shown. For the complete information, you need to go to the complete article, right? See, these are the materials. Complete data has been given in this one. Okay, so I request the younger generation kindly go through our article. Based on the article, you will get complete information related to the amexines and their nanocomposites in the elimination of different kinds of the dye molecules. So 84 amexine based materials have been studied for the degradation of 31 organic pollutants. If you see the conclusion portion, among the 84, some of the materials have achieved the 100 percentage efficiency in the removal or the degradation of the dye. Right, what are the materials which are present, what is the chemistry behind the each and every material, the complete data available in this particular article. So I request all the viewers kindly go through our article and take the advantage from this particular article. Since it is the subscription article, because of that reason I haven't shown the complete data, only the glimpses I have given. So thank you very much.